We got electrostatic interactions. Electrostatic interactions, also known as Coulombic forces, are the attractive or repulsive forces that exist between electrically charged particles. These forces are fundamental to chemistry and physics, governing how atoms and molecules interact with one another. The strength of this force is described by Coulomb's law. Types of interactions. There are two main types of electrostatic interactions, based on the charges of the particles involved. One, attraction, and two, repulsion. Attraction occurs between particles with opposite charges, for example, a positive ion and a negative ion. These are the strongest and most common types of electrostatic interactions in chemistry responsible for forming ionic bonds. Repulsion. Repulsion occurs between particles with the same charge, for example, two positive ions or two negative ions. These forces push the particles away from each other. Coulomb's law. Coulomb's law mathematically describes the strength of the electrostatic force. The formula for the force, F, between the two charged particles is F equals K times Q sub 1 times Q sub 2 over R squared, where F is the electrostatic force, K is Coulomb's constant, Q sub 1 and Q sub 2 are the magnitudes of the charges of the two particles, and R is the distance between the two particles. The formula shows that the force is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. This means the force gets much weaker as the particles move further apart. Relevance in chemistry. Electrostatic interactions are crucial for understanding many chemical and biological phenomena. They are the basis for ionic bonds, hydrogen bonds, and solubility. Oh, that's not a word I'm used to. Solubility. Ionic bonds, where a complete transfer of electrons creates two oppositely charged ions that are held together by electrostatic attraction. Okay. Hydrogen bonds, which are weak electrostatic attractions between a partially positive hydrogen atom and a partially negative atom like oxygen or nitrogen. These bonds are vital for the structure of DNA and the properties of water. Solubility. As polar molecules, those with charged ends dissolve well in all the other polar solvents due to electrostatic attraction. All right. A lot of new information there for me, but cool. We'll probably cover that one again. Electrostatic interactions. All right. Might cover that when we go back to more advanced physics or chemistry classes.